Welcome to the video which demonstrates the tools that Align has produced to support the Seshat use case.
Seshat, the Global History Data Bank, is a massive database of historical and archaeological data. Its purpose is to be able to see the macro patterns that characterize historical processes.
The Seshat project has amassed a unique resource, a vast amount of extremely valuable historical data that is designed to be amenable to mathematical analysis. However, their data curation and analysis system has begun to buckle under the weight of their own success. They use a wiki and specifically coded variables to capture their data, but it is taking an increasingly large manual effort to manage it all and prepare it for analysis. Towards the start of the Align project, we introduced a data validation and extraction tool, which greatly helped them to cut their error rates considerably and greatly reduced the effort required to prepare the data for analysis. Now, in September 2016, we are releasing for trial a fully featured toolset to help the Seshat project to much more efficiently manage the quality of their dataset as it continues to grow. We have developed a suite of software services based on our research to help solve Seshat's problems. These services use RESTful APIs to communicate with one another using RDF, OWL and PROV to encode structure and provenance information and to ease future integrations with other aligned tools. Our model catalog tool provides services which allow users to build data models and apply a range of constraints to them. Our data integrity enforcement framework allows us to test data automatically for a large number of possible constraint violations in real time. Our curation system automatically generates software to allow users to correct, edit, and update their data over time, recording highly detailed provenance information. We have installed the Dakura client as a browser plugin, which has access to the Align services through a secure channel. All of the tools that you see, for analysing the page, the user interfaces, and the validation, have been generated from models. And that's where this journey really begins, with the definition of the model.
The model catalog is a tool to capture, manage, and document metadata. Model catalog users can browse and search for metadata so that that data can be reused. Not only that, the systems that use metadata can be made to work together more easily. Domain experts can use a model catalog to create and refine definitions of atomic data elements. These element definitions can be linked together for richness and classified into reusable models of metadata. The catalog allows prospective data reusers to search for elements and to seek clarification from the original data expert. The model catalog increases the value of data by abstracting metadata into models.
Once we have defined our model, Dakura can use it to automatically generate user interfaces for creating, editing, and importing existing data.
So as you can see here, the Dakura console allows you to browse through content on the web, and we can choose from a number of different collections. We can then choose a particular class. We can then go and add a new element, a new polity in this case. We can add any number of properties, and there are a large number of properties that are associated with a polity. Here we're adding irrigation systems, and if you look through, you see that there is no irrigation system variable present in the current Seshat wiki. Now we can go back and we can see that this is now in the database. We can ask for the various properties of this data point in the database.
The next step in the Dakura pipeline is the approval queue. This allows administrators to perform quality control on submitted data. Admins can correct errors in user-submitted entries, like the typo in this polity name. The update is tested to ensure that it's still syntactically valid, and then updated. After that, the admin can then publish the updated data. The admin can also reject candidates if they do not meet quality standards. Finally, we come to the Model Rapid Prototyping tool. This allows users to quickly test out ontologies from within the browser. Like the data entry user interface, it's automatically generated, and it'll alert users if they don't conform to the schema or if they don't supply required information. New properties can be quickly added and then used immediately. Thanks for watching this video. Stay tuned for further updates.